Hello, everybody. This is Charles Anderson, and I'm just a guy from Goodwill, and I have a wonderful, really great game idea. And we're now on part 6 of the Java Basics tutorial series. We're going to do operators, and I'm going to do this one, after the whole thing with flow control. I'm going to do this thing a little bit different. I'm going to go through the whole presentation and then jump backwards and start playing with it, because playing with it is how I learn. And so I'll throw out the quick information and some other things. Yes, you'll notice there's my mouse, the new logo there. Of course, I had it up from the first one, but after that last bit on flow control, I was like, I need just something a little bit different for my format, because it's more fun if I can type this stuff up, with folks, and although some of it will be just read. This is my new computer. Whoop. Yes, desktop. Oh, right. Yeah. Let's escape out of this. Okay. So yeah, this is my new desktop. Windows 8. I got Windows 8. Woo! And I've got it dual partitioned. You can't see the other partition because that one is in Linux, but I'm now running off of an SSD, so my hard drive can be scanned anytime without having to worry about mechanical failure, and then I can just dump to my mechanical hard drive by plugging it in and rocking with it that way. And so, yes, desktop looks different, reorganized, slimmed down some stuff. I'll be adding in my other programs as I go and getting back into the swing of things that way. So, back to the tutorial series. Okay, yes. And full screen it. Boom. Alright, so we're doing operators this time, and this can go over, one or two things. I don't think it should take that long, but of course, I might just have too much fun. And so for the people who are just coming over to Java from another language, they've already know how to program this stuff, I'll run through the whole thing so that they can just get the compressed information. And, they can translate it into their programming, which is what I had to do with the Java language specification. Oh my God, my eyes bled. But for the people who are wanting to learn and to play with it like a game programmer should play with, then hey, that's part of the fun. That makes it palatable for me. All right. First up, we have unary operators. Unary referring to it works on one value in an expression, or variable in this case, but it results in a value. So we have plus, minus, plus plus, minus minus. This would be the bitwise complement, the logical not, and cast, which, it's a lot of letters and stuff, but it affects the value type that the following expression / variable returns. So, all right. So, plus and minus, as a unary operator, because plus and minus are also additive operators, but plus and minus as a unary operator promote, and promotion, this is something that happens in the background all the time in Java. Non-integer values to type int. I say type int because int is the native integral data type for Java. Integral. Floating, it's actually double for JMonkey Engine. So double is standard for floating operations. Double is standard for floating operations. And integer is standard for the integral types. So, and of course string, it's in a special class all of its own. Seriously. All right. Plus plus and minus minus, the incrementer and decrementer, are considered special operators in the postfix mode. In the prefix mode, they change the value of a variable before it starts. But in postfix, where it's after the variable, they're special operators, as in that they change the value of a variable after an expression is evaluated. So that's just one of the things, and it has to do a touch on flow control. Not much, but it does. And logical not only works on Boolean expressions. So there you go. I want to say that this one only works on bitwise expression, but it's kind of hazy for me there. Let's go on. Next up, we have the binary operators. Well, binary doesn't... the reason that binary is not used for these type of operators is because a computer's binary, and there can be much confuzzlement if I say binary. So, hey, guess what? Additive multiplicative operators is our first of this type of operator. So we have plus, minus, multiply, divide, and good old modulus. They're used with the number types. Plus is also used for string concatenation. So yeah, adding strings together is also used with this little plus operator. And modulus is used to find the remainder of a division. That's for people who, don't know that part of programming, and of course we'll be playing with that later. And can be used with floats. This would be for the intermediate. You can use these with float numbers to help prevent loss of precision. And of course, just think any calculation involving pi. Eesh, pi. At 22.7 is close-ish, but pi is just a wee bit under that. So 22 divided by 7, I actually, there's some poetry right there. Pi is not 22 divided by 7. It's close, but pi is a beast all of its own. All right, next up, shift operators. Yes, the good old left shift, right shift, and unsigned right shift. Move bits left and right. And this boils down to some of the binary stuff that we'll be playing with. Bitwise stuff that we'll be playing with. An easy way, shorthand, it's an easy way to multiply and divide by powers of 2. But not 10, because this is binary, not decimal, which is what we tend to read in. Right shift is a signed bit shift, which preserves the signed byte or signed bit. This is quick and simple. Helps you to get through a number really quickly. And the unsigned bit shift to the right can destroy the signed bit. There is actually, to do with numbers. I'll go into that when we work with it. But if you really want to see how the computer sees a negative number, you'll use this. And I do have this ready for the fun stuff. All right. Next up, we have relational equality operators. So less than, greater than, less than or equal to, greater than or equal to, instance of. So those are the relational. Now the equality operators are is equal, is not equal. And those are used for Boolean expression. Well, all of these are used for Boolean expressions. Okay, so less than, greater than, less than, equal to, and greater than and equal to are used for number variables to make a Boolean expression. Instance of is used to make a Boolean expression for reference variables. And yes, there is that little type variable. I'll boil it down to this is used when we're trying to decide if we did a correct cast when we cast a superclass as a class. More on this in classes. So this one will be ignored for this part of the lesson. More on this in classes. It's right here so that heads up. We'll be covering that in classes. All right, and then the equality operators equals and not equals are used for numeric Boolean expressions, Boolean expressions, and reference variables for Boolean expressions. So watch out. This one can be used for a lot of things, and it's up to you, or well, it'll be up to us to make track of what we're evaluating with these two little beauties right here. Don't worry, the compiler will say, hey, are you really sure you want to evaluate it like this? So it'll help keep you straight on it. All right, next up, bitwise and logical operators. Now, again, the binary bitwise level, and XOR, OR, and strictly logical and OR. Operators that play on the bit level for fiddling with stuff. These are best used with Boolean expressions and enumerations as flags. Enumerations will be covered later. It's a type of class that, it has words and, strings, and they can be attached to numbers, and these numbers can be on the power of 2, bitwise, to do these flags. Great in video game event tracking. So, boom, there's that. Okay, double and double OR. Well, yeah, I'll call it double and double OR. Were created to make Boolean expression evaluation faster. So, and is kind of like this and. Double and is kind of like this and. But this is strictly for Boolean expression. It cheats if the first value is false. So in other words, if the first, first value, Boolean expression on, the left side of this is false, then it just skips the other side. It just skips that. So, it's kind of like a flow control, but yeah, it jumps. So you can use double and to make your code faster on a tight loop. And double OR cheats if the first value is true. Because, on an OR, it can be one or the other. So if this one's true, it doesn't even have to evaluate the other. It just goes. So, let's see. Yes. In reference to the earlier unary operators, the exclamation point is a not for those, transferring over from code. For Boolean expressions, complement, or the tilde complement, is a not bitwise, and then we have the and then here's something that new for people who aren't familiar with programming, the XOR, which is one or the other, but not both. It's exclusive OR. So yeah, that one, that's why it's definitely different from OR, and I'll go into that more on when we get to playing with it. And then finally, OR, which is one or the other. Okay, and let's see what's our next one up. Assignment operators. Yes. All right. So here's the full list of assignment operators. You have your equals. This one's the easy one. Then we have plus equals, minus equals, times equals, divided equals, modulus equals, left shift equals, right shift unsigned equals, and equals, exclusive OR equals, and OR equals. So this is the complete set of assignment operators. And yeah, the bitwise complement equals is not in the list, and the not equals is already used for something else. So, now note, because strings accept the plus sign, plus equals works for strings like plus does. So when you do like my string plus equals something, that's like saying my string equals, there is a cast of string class, my string concatenation with something. It can be a number or something because it's concatenated to the end of my string, like that special my string, string class does. All right, and all of the others translate similarly. So here I declared a byte, my byte. Ow, boy, there's a misspelling. Yeah, pretend it's a y. Okay, pretend that's a y. Okay, and I just set it to equal to 10, so it's declared and set. And then here's one way of saying it, which is my byte divided equals 5 colon. So when you boil it down to what the compiler sees, it's my byte equals a casta type byte because it naturally promotes all bytes to integers for operation. Yeah, promotion. I'll go into that. And so we have my byte divided by 5, and then that's converted to a byte and stored in my byte. So that's the longer form of saying it. Otherwise, you can just say it like this. And this is definitely cooler to look at. Well, shorter, that's for sure. All right, let's see what we got next. Ah, yes, the final operator in the list. Now, I've already covered this in the if-then-else. Well, let's see, what was it, flow control 2? But yes, this little question mark and something and the colon, it's the only ternary operator. So a ternary operator is there was unary, works on 1, binary, works on 2, which all of those others are called something else. But yeah, and this one is a ternary operator, which means it works on 3 things. So it's like a quick if-then-else statement. It can be nested. Yes, it can be nested. But this is a stack operation. So it starts going from right to left. Yes, you can play with that. I probably won't play with that unless I get really intrigued to do so. I probably won't. But yes, last in, first out in a stack. In other words, like a stack of papers. The last one on the stack is the first one that you can grab off of that stack. So there you are, last in, first out. Stack and heap, concepts covered in classes. So yeah, don't worry too much about this stuff. But yeah, right to left, it's interesting. I will not show that example. It is possible you will see an example in the Java language specification. So example time. Let's see here. So we have an int, my int. And why did I capitalize that? I don't know. But anyway, all right, automatic capitalization done by this processor. Okay, so anyway, we have equals Boolean expression. Well, a Boolean expression does not get promoted to an int, but it gives it the heads up. Oh, hey, question mark. So if this is true, then it equals this. If this is false, it equals this. So if this is true, here, else that. There we are. That's it in a nutshell. And I've used it before, but because it is an operator, I'm listening in again. All right, so those are the official credits. I'm Charles Anderson, indie game developer, Project Idiog. I've got an email. I've got a Twitter. And now, let me check my time, because I started this up about, 10 minutes ago? So, let's start by going back up. And now let's play. For those of you who are just tuning in and just wanted to know the quick and dirty, translation from it, yep, there you go. And now we start to play. So let's start with the Unary operators, and let's fire up good old JMonkey engine here. Oh, wait, that's the hub. Oh yeah, by the way, I'm on this forum. Okay, there's my JMonkey engine. Okay. So yes, I've already got some stuff in here, and I'll just go over it right quick. I made sure to bring in a scanner just in case you want to play with a scanner. Throw in a scanner. But in this case, I'm going more over bitwise operations. I've got a car, my car. Got it. My character. Okay. Integer, my int. I've got a double, my double, and I've got a boolean, my bool, and I didn't finish my comments, but that's all right because I'm doing it live, so that should be just fine. Okay, now you'll notice that I have a couple of functions here, and these are some helper functions, and I will go over them. I guess because here's public static. This gets more covered in classes, and this is a method, but it's there. And of course, I've got my control variables in here, and I'm using that unsigned right here, and a couple of fixes to make sure that the printout looks good. But I'll be using toBinary to show off the bitwise operators. And then, of course, I've got a here's to pi, which this is greater than pi, but this shows off kind of, yeah, go on ahead, go for it. So, yeah, because pi, what can I say? What is pi? Let's get this out of the way. All right, so I'm going to suggest, okay, I'm being in it, yeah. I'm going to suggest Ask Dr. Math, okay? And it says, okay, something weird here. And yeah, well, it equals pi-ish, but you have to follow this form. And then it says, oh, hey, guess what? As a number that cannot be written as a repeating decimal or a finite decimal, you can never get to the end of it. Pi is irrational. It's an irrational number. It cannot be written as a fraction. 22 divided by 7 is kind of close, but that's about it. All right, so there we are. And let's go to the other source. The other source, which is good old Wikipedia. And oh, okay, gotta wait. All right, here we go. Yes. Yeah, here's a picture of that whole circle thing. And oh, you're still loading, aren't you? Wow. Maybe I should have preloaded it before I started the video. But anyway, yeah, as you can see, there's a little bit more, yeah, math. Yeah. Ooh, yeah. Can you read this? Nope, neither can I. And, oh, wow. Now, I will say that some of the video game stuff kind of reaches this, but yeah, we only work with triangles and maybe some big stuff. But yeah, there you go. You want to get a headache? Yeah, just try to understand pi. So yeah, we'll just focus on 22 divided by 7, which is kind of close. And so yeah, those two I'll be breaking into. But let's start with the unary operators. Okay, so unary operator plus. Okay, so I'm going to be using my character. All right, and we'll use. Oh, I guess I'll go like this. System. System dot out dot println. Alrighty, and we will print out my character without any special treatment. Okay, and so run it. Oh, there it is. Pretty simple. Yep, there's a $sign. That's what we signed it. Alright, now, notice I had this quote right here. 0x24, that is hexadecimal. I could also write this as escape character U0024. And when I play it, oh, there it is. And I can write this as 0x0024. Yep. And there it is. I can write this as 36. And it's still the $sign. Now, why am I showing all this? Well, it's just showing, a play of numbers like I showed from the variable types talk. And so here, what we're going to do, we're going to put this little plus in front of it. Okay? Unary operator plus. And now it is 36, which is a number. So you can print a character as a number, with the print line. So, woohoo! Yes, so, and now that's what it does, is if it can be read in a string as a character, you can convert it on the character level to its number. All right. Next up, yes, you could write. You could totally write like a when you press a letter or number on your keyboard and you hit enter. You can read that character and then say what its Unicode string was. Boom. There you go. That's the possible application of that little plus. Next minus is just the same thing, except it's minus. So, minus 36. Go figure. Now, this actually has an application to this program right here, because this minus sign, anytime a negative is involved, it will print out a minus sign and slip it into a string if a minus sign is involved in here, because something to do with that unary type right here. Okay, so let's start treating my character as an int. In other words, like this. So post increment, or well, let's start with pre-increment. So pre-increment will actually change the value of my character before this statement prints. And what we can do is we can do this, and Control V. All right, there's my character, just my character, and this one shows off what this one does. All right, so we go play that, and we have the little percent sign, or well, modulus. That it's percent sign. That's what it is. All right, and if I turn it into the postfix, and notice this is only 1, the integer 1. All right, and there's after the change, and so I'm gonna keep on with the postfix for minus as well, and it goes the other direction. Now to see this in action, there we go. So it was 36, now it's 35. And then plus. It was 36, now it's 37. And so there we go. We just combined this stuff right here. Now, here's where we start to get a little binary right here. This is the bitwise complement. So, how can I do this? Well, let's flip over to an int. And let's go ahead and set this equal to 36 like my character. That way I don't have to do this. Now, believe it or not, if I wanted to do a prefixed and then a plus my character, it would look kind of like this. Yeah. That's how that works. Try it. Yeah, you can play with that too if you want, but yeah, it's just a headache. So I'm going to switch over to int. So my int, and we'll go ahead and get rid of this line since we're flipping over to integer rather than character. Now, my int, let's do that. We're still at 36 for an integer. Now, watch what happens when we do this thing. Okay. Now, this number will go negative something d weird. Negative 37. Wow. Did it just gain 1 and go negative? I mean, it's kind of like this, but it seems to be 1 off. Oh yes, you're about to learn a secret of math in Java and how a computer really sees it. Because let us now see my int toBinary my int. Okay, this is what the computer sees. And this is binary, and I've written it out in binary notation. So it goes ones digit, two digit, nothing there. Fours digit, that's plus 4. 8, 16, 32. So 32 plus 4 is 36. So powers of 2 as you go up. That's binary. Like powers of 10 for our normal number system. Okay, so let's show off what happens when we start complementing. All right, so first we do the minus sign. Okay. Okay, that's what it really sees. I'm going to switch over to the shorthand. And that. Okay. So let's play it. All right. There it is. So minus, and there it is. That's negative 36, just like before. And what happens with 1's complement is that this little adjustment for good old 0 doesn't happen. Okay. It just flips all the bits. So when we press play, this bit gets flipped too. Wait, what? Yes, yes. So something happens here where a direct flip happens. And now I will show this off with good old negative 1. So when we do, oh, well, let's see. Let's show them what the computer really sees first. Okay. So let's go false. And add that one right there. Okay. And let's go with well, 0 is going to come out short because it should be short. There it is, 0. All right. But on the other end of the scale is negative 1. Okay. So we play that. And you'll see all this. So what does this mean? Well, what it does is it does a complement and then moves it by 1. Because if I were to do complement 1, all these were literally zeros with just 1 right there, but then it complemented it, bam. So if you think of how it treats a negative number, well, it does a bitwise complement and then adds 1. That's how it goes. Yeah. And for hilarity, I will also now complement 0. Bam. So negative 1 equals the complement of 0. Go figure. What it has to do is this bit right here is the negative sign bit. So when you start doing shift left and shift right, this gets moved around too, and that's what I took advantage of for that operator. I'll go into that on the shift left and shift right. Okay, so but I've shown a little peek through that window. The important part is, guys, play with it. That's what's fun. Okay, so we have not. Not is up next. So, all right, let's get a Boolean expression going. Oh, here's a Boolean. So right now it's equal to false. And so if I print it, my boo, and we play it. Well, it's false. Yep, that's true. And now to not it, and press play. Now it's true. So it's like a Boolean is considered to be 1 bit. All right, and it takes up more than 1 bit. It's almost like a byte. But that's why there's only true or false, just like one of those bits. And this is why this works on Booleans, and this is more meant for numbers. If I were to try to do, I wonder, will this work? Only one way to find. Oh, what is this? Bad operand type for Unary. Okay, so not allowed. All right. Yeah, stuff to play with. All right, so now we've gotten through that one. Now we're up to cast. All right, so cast. Okay, like int. Yeah, we can cast it as an int. My double. Yes, my double. Why not? My double. Let's give it something. Why not? 1, 2, 3, 4, 5. Yeah, that'll work. Yep, there it is. 1, 2, 3, 4, 5. And now, what we can do is we can turn a double into an int. Why not? We can do that. So let's cast. Here, we're starting up our cast. Int. Okay. And the reason that you need to do cast is there's times when you're going to lose precision. And here's why. Whoop, now it's just 12 because integers don't have decimals and floating points and stuff like that. That's crazy talk. What you talking about? Also, like, we can take my character, that whole thing. Let's see. My character. And casting it as an int. Oh, there it is, 36. And now we can take my int and cast it as a character. And press play. And now it's a $sign. So, yeah. Hey, guys. There's cast. It lets you play with the code. Just make sure not to go running off with it. It will probably mess you up if you go too far with it. Alright. So, that wraps up Unary operators. And let me check my time. It's 55, so that's about 30 minutes. That should be good for this first one. I'll get the next one ready and get that up as soon as possible. So, let's head over here and, for now, do the credits for this first part in the operator series. Of course, I'm using JMonkey Engine in Java, and my name's Charles Anderson. I'm an indie game developer. My project's Idiog. My email is relic724@gmail. Got a Twitter account, all that good stuff. Y'all have fun with that little bit, and get ready to play with some more stuff on the following lesson in the series. All right, y'all have a good one.